As we all know, electric vehicles are becoming popular day by day. The EVs are not yet achieving the number as it should have been, mainly due to the limited range and higher cost. The limited range on the battery is one of the major drawback for the EV currently. In case of rickshaw, the average run of rickshaw is about 200 to 200 kilometer in one full tank of fuel, whereas the battery can give about 80 to 120 kilometer range. It means the batteries need to be charged during the day. The average charging time on level 1 is about 4 to 6 hours depending on the battery capacity, or about 20 minutes on level 2 charging system. The rickshaw driver can wait for 20 minutes for charging batteries between two trips or during lunch. It is less than the time he waits for CNG on a filling station. The other alternative can be a battery swapping. The battery swapping can be done much faster. However, the battery ownership need to be a third party. The investment in the battery will be very high. For 1000 rickshaw, at least 1600 batteries need to be in pool, and it may cost about 15 Cr for the batteries and the charging station. Since the range is limited, the charging stations are very essential at a regular interval to make it convenient for the user to take the EV for a longer distance. Government has recently announced that the Indian oil petrol pumps will have the EV charging facility soon. This is logical as over the period the fuel consumption will go down and the EV charging requirements will go up. So the existing infrastructure can be used effectively and efficiently. In order to make the EVs a grand success, charging station availability and charging required time are very important consideration. In general, onboard chargers are slow charging system which can be which can take between 4 to 8 hours for charging a battery. So specifically when one wants to travel longer distance, the charging station is necessity. The estimated number of EV on road by 2024 is about 16 million, for which at least 16,000 charging stations will require. The number of charging station installations are increasing at a fast speed and likely to grow at 22% CAGR till 2026. Level 2 charging stations dominate the market worldwide. Over 90% of the market is acquired by AC level 2 charging. However, the DC fast chargers and wireless charging technology are picking up at a fast speed. In DC, we have an option of going up to 350 kilowatt hour rating, and it does really fast charging. DC fast charging is mainly considered for charging city bus, and the other AC chargers are used for a normal charging. For a charging in-house, the AC charger will have a capacity of up to 22 kilowatt. That means a car with about 22 or 25 kilowatt hour battery will get charged within 1 hour. There are a lot of different business models are evolving, and according to the charging station capacity and the requirement, the revenue generation will vary. Charging equipments are classified by the maximum power it can deliver to battery for charging. For AC charging, there are two levels. Level 1, which operates at 120 volt AC and popular in the North America. The charging rate is approximately 1 kilowatt per hour. This means a battery of 4 kilowatt rating will take about 4 hours for charging, whereas the battery of 1.2 kilowatt will take little over 1 hour. Level 2 charging stations operate at 240 volt AC, and the charging rate is between 3 to 20 kilowatt depending on the input power. If the input power is single phase, the maximum charging will be up to 4 kilowatt, whereas with 3-phase input supply, the maximum charging capacity will be about 20-22 kilowatt. This means on a single charger, on a single phase charger, a battery with 4 kilowatt can be charged within 75 minutes, and a car battery of about 25 kilowatt can be charged within an hour with 3-phase input supply. DC fast charging stations are starting from 50 kilowatt onwards up to 350 kilowatt rating, and they all operate between 600 to 1000 volt. The city bus battery with 180 kilowatt can be charged within half an hour, and a battery of 120 kilowatt can be charged within 20 minutes with the DC fast charger. It is expected that most hybrid and EV owners will charge their vehicle overnight at home. Level 2 charging equipment will be the primary option for home charging. Vehicle manufacturers have already developed the chargers suitable for such application. Standardization in charging outlet assures that all vehicles can be charged at any charging outlet. North America had agreed on standards. Many European countries are discussing standards for charging infrastructure, and they are in a process of finalizing the suitable charging infrastructure for the country. Standards for charging in India are designated as Bharat EV Charger AC001 and Bharat EV Charger DC001. The home charger or onboard charger use 230 volt, that is single phase line, with maximum 15 ampere current, which delivers maximum 3 kilowatt of power. The recommended connector for this charger is IC60309 for both the ends. Fast AC charging. Onboard AC fast charging is done at a rate of 7.7 kilowatt to 22 kilowatt maximum with 3-phase supply at 415 volt. Cars like Nissan Leaf have onboard chargers capable of fast charging at 22 kilowatt hour rating. This slide is showing the schematics of charging. For AC charger, supply from mains or grid is given to the EV service equipment, which supply power to onboard charger. Onboard charger convert AC supply to high volt DC for battery charging. In DC charger, the grid supply is given to EV service equipment or a charger, which converts AC to the DC supply, and it is supplied directly to the battery for fast charging. In case of AC supply from EV service equipment, the supply goes to onboard charger where it gets converted to high volt DC and then it is supplied to the battery. Whereas in DC fast charging system or DC charging system, onboard charger is not coming into picture and supply is given directly to the battery. This is the basic difference between AC and DC charging system. Here we are talking of a level 2 and DC charging. So what is the difference between level 2 AC and DC charging? Will be discussed here. In case of AC charging station, the AC power is supplied from the charging station to onboard charger. which gets converted to DC power and then it is supplied to the battery. Whereas in case of DC charging, the EV service equipment supply DC power directly to the battery. In this case, the onboard charger is bypassed and power is supplied directly to the battery. Here we are discussing the charging time required for different battery ratings with different type of charging stations. The level 1 charging is basically for domestic use at 2 kilowatt rating, which is mostly used in US. The level 1 charging up to 3 kilowatt is mostly used in European domestic application. Level 2 20 kilowatt 3-phase input for domestic or industrial or public charging is used almost everywhere. And level 3 50 kilowatt DC-DC charging and above is used for public spaces and fast charging stations. DC-DC charging is mostly used for uh, heavy batteries above 50 kilowatt, and the common application is city bus. Here the charging efficiency is considered between 85 and 90% for different applications, and for different batteries what will be the approximate time for charging is discussed. So if it is a electric bike with 0.5 kilowatt battery and the battery rating is 20 ampere, it will get charged to 80% between 0.2 hours. The plug-in hybrid EV will take battery of 10 kilowatt and the maximum charging current can be up to 41 amperes. It will take approximately 0.5 hours on level 2 charging. Whereas EV passenger car with 24 kilowatt hour battery can charge at maximum 66.2 ampere at 85 efficiency. It will take approximately 1.2 hours for charging the full capacity. And heavy duty battery for delivery van or bus at 50 kilowatt hour rating will take a maximum current of 200 ampere and 90% efficiency. Level 2 charging, it will take 2.2 hours for charging, whereas at 50 kilowatt it will be hardly 20 minutes. For ensuring the compatibility of the charging stations and the vehicle, Bharat EV specifies the use of particular plug with number IEC 60309, and this particular connector is mostly used on rickshaws, whereas the plug type IEC 62196 type 2 is connector used for charging. The different plug as per the different rating ensures that the batteries are charged with correct supply voltage and the correct levels. If the any other charger, if you try to connect on this, it will not get connected and the batteries will not charge properly. Here in this slide, we are showing a different type of chargers available for charging the equipment. On the first block, it is a standard domestic sockets and the domestic plug used for level 1 charging. This is mostly used for charging two-wheelers. On the right hand side of this first block, we have type 3 coupler, which is basically used for AC charging, and it is a fully safe coupler. On the right hand side, it is a scheme AC plug with safety shutters. On the bottom, we have Mencken's AC coupler. Then we have type 1 AC coupler. Then there is another type of AC coupler, and we have DC combo coupler on the right hand side. This indicates that a proper coupler will match only if the suitable socket is there. Otherwise, it will not match and you will not be able to charge the vehicle unless you have a correct socket on the charging equipment and correct plug to match it. This slide is showing CHAdeMO DC plug and China GB standard DC plug as well as AC EV charging plug in China. On the bottom, we have CCS connector, which is mostly used in European countries. And on the right hand side, it is shown that the CHAdeMO DC and AC sockets mounted on the Nissan Leaf. Here in this slide, a different type of AC charger sockets and the DC charger sockets are shown. The AC charger sockets are Yazaki socket having a rating of 7.4 kilowatt used with single phase supply. It is commonly used in Japan and USA. The second charger Menken socket, which is having 63 ampere maximum current, three phase input supply, and it works up to 44 kilowatt capacity. It is used in Europe and Germany. The Legrand type socket is used with three phase supply, maximum ampere is 32 and maximum charging power is 22 kilowatt. It is used in France and Italy. Now we move to the DC charger. The DC charger CHAdeMO type is used for 1000 volt rating up to 400 ampere current and charging power is 400 kilowatt. It has a CAN protocol. It is used in Japan and Korea. This connector is installed on Nissan Leaf, Kia and Mitsubishi Motors. The next one is GB connector, which is having a maximum capacity of 237 kilowatt. It works at 950 volt and draws a maximum current of 250 ampere. Again connected with CAN protocol, used in China and India. It is used on Mahindra and Chinese EVs. The next one is Tesla supercharger, having a rating of 135 kilowatt. Maximum current is 330 ampere and three-fourths supply of 415 volt. Again, CAN protocol. This is working on all Tesla charging station and using on Tesla S and Tesla 3 car. The Type 2 AC charger, which is used mostly on the car in India, is having three-phase input supply, can work up to 400 volt and maximum current of 63 amperes can be drawn from it. The power is 43.5 kilowatt rated. The CCS DC charger is having maximum 850 volt and the current rating is 200 ampere. The power rating is 170 kilowatt. This works with PWM and PLC communication. The CHAdeMO DC charger can work up to 600 volt or 200 ampere and the connected power maximum is 120 kilowatt. The GB/T type DC charger works up to a voltage of 750 volt with maximum current of 250 ampere and a maximum power up to 187.5 kilowatt. It uses CAN type communication. Here we can see the different type of AC and DC chargers used in different areas. The US is using single phase AC charger SAE-J1772 type for standard vehicles as well as hybrid vehicle. It is using DC type charger. The European Union is using AC 62196 Type 2 charger and Type 1 charger also. For DC, they are using 62196 stroke 2 type charger. China is using Type 2 charger. China charge couplers are not standard yet, and they have different chargers, have unique control analysis, and overall physical shape varies compared to other chargers in the world. Japan is using SAE J1772 charger as a single phase, and the standard has unique control signals and overall physical shape match internationally. Whereas for DC charging in Japan, charger type G10519993 model CHAdeMO is used. In this slide, we are showing how the AC charging infrastructure and the architecture is working. We have a vehicle to charge. We have a EV service station. We have a communication system, control and monitoring system. We have a mobile application with the end user. The EV charging station or the charger communicates with the monitoring system as well as with the EV. For this, you need to have a guarantee safe and secure supply of energy for battery to the charger, and the charger will provide the accurate supply to the electric vehicle. The EV-SV and CMS communication is very important to handle the grid related parameters, user authorization, billing, and other information related to the charging. Communication between mobile app and CMS is important for locating nearest charging station, reservation, billing details, etc. Here in this we are showing that a DC charger with 400 volt and DC charger with 1000 volt, how long it will take to charge the batteries. On the left hand side, a 50 kilowatt battery with 400 volt charging can be charged within 80 minutes. Whereas if it is limited by a plug of 200 ampere, the 80 kilowatt battery will get charged within 50 minutes. The limited cooled plug and battery cells of 300 ampere can charge 150 kilowatt battery in 29 minutes at 400 volt. On 1000 volt, 2000 kilowatt battery with 200 ampere plug can get charged in 19 minutes, and 350 ampere plug it can get charged within 11 minutes only. So here we can see that as your charging power goes up and up, the charging time is coming down and down. Basic architecture of the charger is shown. We have a single phase supply coming to the charging station. The charging station gives information to metering and billing. In charging station, you have fixed AC supply and the safety interlocks. This gives the AC supply to the EV charger. At EV charger, the EV AC supply is converted with rectifier into DC supply, which goes to the power control unit and DC-DC converter. From here, the variable DC supply goes to the protection circuit, and constant current and constant voltage is supplied to the battery for charging. The battery communicates with BMS, that is battery monitoring system. The battery monitoring system communicates with protection circuit and the power control unit. So this is how the AC charging is working. In DC charging, again, we have a AC supply, we have a charging station which have a variable DC supply which has a safety interlock which gives information to metering and billing, and the variable DC supply is given to the protection circuit. From protection circuit, constant current and constant voltage supply is given to battery for charging. Battery monitoring system communicates with battery and with the protection circuit. It also communicates with the charging station. And this is how the complete cycle is completed. In the DC fast charger, DC current is supplied to the battery directly via the DC charge port. DC fast charge rates are usually 50 kilowatts and above, up to 350 kilowatt. They supply usually a range of 100 kilometer per hour of charging. As per the Bharat DC charge specification, power rating for fast chargers are starting from 10 kilowatt and going up to 50 kilowatt. The standards are 10 kilowatt, 15 kilowatt, 30 kilowatt and 50 kilowatt. The chargers above 50 kilowatt are 100 kilowatt, 150 kilowatt and 350 kilowatt rating. The voltage range for Bharat DC charging is 48 volt, 72 volt, etc. For electric car like Mahindra E2O, Plus 8 and E-Verito, this type of charging is used. Up to 750 volt or higher voltage is used for other cars like Nissan Leaf and other. See a schematics of a commercial charger charging multiple cars at a time. We have a grid supply, 3-phase 415 volt input coming to the input filter. There are line rectifiers which convert the DC voltage. This DC voltage is going to the individual charging port where there are control units and the DC-DC converters. DC-DC converter and control unit is communicating with each other. At DC-DC converter, the DC voltage is controlled and the constant current and constant volt supply is given to the vehicle for charging. We can have multiple number of charging ports on one unit depending on the rectifier capacity. Here we can see the simple wiring diagram for DC electric vehicle. The diagram shows the bare bones wiring for the traction circuit in a typical electric vehicle with DC series motor and the controller. So here we have two batteries. One is for the low voltage and one is for the high voltage. The high voltage battery is considered or called as a traction battery, and the low voltage battery is called as auxiliary battery, which has a supply of 12 volt for control circuit. Nowadays, instead of using two batteries, the common battery is used for both the applications where the lower voltage power supply is tapped from the same battery, and this is mostly used for the higher capacity batteries. So the low voltage control circuit supply is going from battery to the fuse, from fuse to on off switch, from there to inertia switch, and from there to emergency button. From here it goes back to the charging system and cold spark. In traction battery, the supply goes from battery to the controller through fuse and control circuit. The controller gives supply to the motor, and the pot box or the variator gives signal to the controller which increase or decrease the speed of the motor. And that's the basic simple wiring for electric vehicle. As we have seen, there are different ratings available for DC fast charging stations. So here we have given a table showing the different type of DC fast charging systems ranging from 50 kilowatt to 350 kilowatt. All the systems have an input voltage of 385 to 440 volt AC. The output voltage is in the DC form, which varies from 50 to 500 volts. And in higher ranges, it goes up to 920 volt, like for ABB Tera HP. The current rating on this in the DC is 120 ampere for 50 kilowatt rating charger and 375 ampere for 350 kilowatt charging station. Up to this time, we have been considering electric vehicle only as a energy consuming equipment. However, in future there is a possibility that the energy stored in the batteries can be given to the grid when there is a high peak demand, and the system is called vehicle to grid. Here the grid will give supply to the residential use. From there it will go to the meter, which has a vehicle to grid unit meter, and from there it will go to the electric vehicle. The control unit will control the charging when there is no or limited load on the system. During the high peak load, it will draw the current from the battery and give it in the grid. So vehicle to grid system describes the system in which plug-in electric vehicles such as electric car and plug-in hybrid vehicles communicate with the power grid to sell the demand response services by either returning electricity to the grid or by throttling their charging rate. Since at any given point of time 95% of cars are parked, the batteries in electric vehicles could be used to let electricity flow from the car to the electric distribution network and backwards. This represents an estimated value of the utilities of up to $4,000 per year per car. So using stored energy from the car and feeding it to the grid also is going to be a big business and lucrative business in future. Here we are talking of a commercial charging station which can charge one car or two rickshaw at a same time. The origin of the charging station is from Europe. The manufacturer is well established manufacturer having multiple units deployed at multiple locations in Europe and America. The charging station comes with single volt or single phase input current as well as three phase input supply. At single phase input supply, it will have a maximum current capacity of 16 ampere and it will give a maximum power of 7.4 kilowatt output. At three phase input supply, it will give a maximum current of 32 ampere or the maximum charging capacity of 22 kilowatt. It is equipped with type 2 socket and the charging mode is mode 3. The equipment is having lot of additional facilities like RFID cards, mobile application, etc. etc. The weight of the system is hardly 60 kg and these are very attractive column type charging station which can be deployed on the fuel station also. If anyone is interested, they can contact us directly. In case if you need any additional information on the subject, or if you want to know the design consideration and selection of charging station or any other information or consultation on the EV related subject, you are most welcome. We are project consultant having over 44 years of experience in the local as well as international market. Our international market experience is more than 20 years. We have successfully completed over 24 projects with customer base in India, Kenya, Tanzania, Nigeria, South Africa, Kuwait, etc. We give services in the turnkey projects, technology transfer, and energy saving. You will have one-stop reliable services from us and you are welcome for your requirements. Thank you.